Hello, this is Ioannis, Solution Engineer with SimScale. Let's explore SimScale's commitment to hydrogen. Hydrogen is quite popular ingredient nowadays that follows a really long journey from production till the final end consumer. With SimScale simulation, there are numerous of different applications that can fit and help engineers using SimScale create a better, more efficient product. Here I list a couple of typical applications that can be used with hydrogen modeling, starting from filtration and standard flow control up to stress evaluation with a mechanical or a thermomechanical analysis. So today we'll see how with SimScale you can start by bringing in your CAD model to the necessary preparation in the cloud. Use the right material models for hydrogen, either the perfect gas law or the real gas law via tables, and then run parallel simulations, being able to create design spaces within minutes instead of having to wait hours or days compared to the standard local hardware infrastructure. Here I am inside the SimScale Workbench where I have already uploaded a safety valve model. So in this case, I can use SimScale's CAD mode and progressively pre-process the geometry to bring it in the final level that will be used for simulation. For example, I have already created a symmetry model where I only see half of the model since it is going to be a perfectly symmetric valve. But then I can continue creating the next steps, for example, extracting the fluid volume, right? Creating the opening of the valve, and finally just removing all the unnecessary components and just keeping the fluid volume which is going to be used for this simulation. Once you are happy with your model, you can go ahead and create a new simulation. The first thing I want to do is enable compressibility and then choose the proper material. So I'll just browse quickly in the SimScale material library and select hydrogen. When it comes to hydrogen modeling or any other compressible gas modeling, you have many options. First of all, you can model it as a constant density, and that's quite okay if you are doing low pressure difference flows or low speed flows. But since we are doing we're talking about hydrogen, which is typically quite compressed, we want to use either the perfect gas law, which will assume an ideal gas and to assign the relevant material properties automatically, or to be more realistic, we can go ahead and use the real gas option. Selecting real gas, I can easily upload density and enthalpy as a function of pressure and temperature using CSV files. Now, I can quickly create the boundary conditions with a few clicks. So on one side, I want to create a pressure inlet. Typically, we work in bar, and let's say we are at 50 bar. And typically, we also cool down the hydrogen a bit. So let's go down to minus 40 Celsius. And on the other side, I want to create a pressure outlet. Before I run the simulation, I can also quickly create result controls at the outlet and at the inlet. And this will help me monitor quantities like, for example, the mass flow or the volumetric flow at these surfaces, and then help me also post-process the results more efficiently. That's it. I can go ahead and start a new simulation in the cloud. Now I have my first simulation running, but what's the power of SimScale is that I can quickly go back and run a parametric design study. Say, for example, I want to study different pressures, 10, 20, 35, and 60 bar. This will now launch all the 4 simulations in parallel. So instead of having just one simulation running, I now get 4 of them running at the same time, meaning that if one takes 20 minutes, all four of them will still take 20 minutes because they are simulated in parallel. All right, Let's go ahead and look at some results. Here I have already simulated real gas and perfect gas model, but let's go ahead and see the results for the real gas. I can click the finish simulation and post-process the results. As all the setup, also the post-processing is done in the cloud. Now I'm inside the live post-processor and I can create a cut plane and check the pressure, center of the valve, and I can also create another one and check the velocity, and of course create nice visualizations like, for example, streamlines and particle traces that can be easily as well animated. All right, we've seen how in less than 5 minutes we were able to set up and simulate from scratch a highly compressible high-speed hydrogen flow through a safety valve. We were also able to simulate multiple designs in parallel and do the post-processing in the cloud using the power of SimScale. Thanks for watching.